let's go back to here, and let's read a little bit more about what we did. Okay, we already looked at this slide. And here, he's just describing what happens. So let's just read through this part here. Oh, sorry, this is different. So here's calculate the sum of all integer values, in other words, all integers, from 1 to 10. In other words, add up, do that problem that we were looking at earlier, 1 plus 2 plus 3 plus whatever we said, but this time we want to go 1 plus 2 plus 3 up to 10, right? Okay, so let's try and get that one. How would we write that? Okay, use a for next loop, also known as a for loop. With the loop variable, we'll use I, and we'll use that both as the index of the integers. In other words, it's going to be used we're going to use it in the statements, the green part here, and it's also controlling the loop. Okay, like I said, it doesn't always have to be in here. Okay, but we are going to use it in here. So it's going to be the index of the numbers, right? And and the variable total to store the sum. So we're going to declare a variable called total, and that's where we're going to keep the answer. Okay? So we're going to start it out at 0. Okay? So we're going to declare total as an integer, but it's going to start out initially as 0. And then we want to write a loop. And what do we want the loop to do? So what we want is we want to add one plus 2 plus 3 plus 4 plus 5, so on, right? Up to 10, right? So what we can say is we want to do like 1 plus 2, and then we want to take that, get that result, and then add what to it? 3. And then we want to take that result and add what to it? 4. So what we want to do is we're going to have total. First it's going to be equal to 0. Then we're going to add 1 to that. So total will be equal to what? 1. And then we're going to add what to total? 2. Right? So we have 1 plus 2. So total will be equal to 3. And then total is equal to 3. Then we want to add what to that? 3. And that will give us 6, and so on, right? That's the idea. So what we do is, let's look at it. Total starts out at 0. Now I starts out at what? At 1. So what do? We add I to total, right? And total now is what? 1, right? And then what? Now we go back up again. I is equal to what? 2. So we add 1 plus, here this was 1, now we add 2, and we get 3, and so on, right? And total is what? By the end, total will store the total, right? Everyone agree? Okay? And actually, at the end, total will be equal to 55. Okay? Do you know the formula for summing up 1 to n? What's the formula? N times n plus 1 over 2, right? Did anybody know how to prove that? Some people do. It's easy to prove. What? What's this equal to? Oh, sorry. What's that? So by that I mean this, right? 1 plus 2 plus 3 plus n, right? That's what if you want just this, but this is the symbol for this. Okay, if you just want to say, what's this equal to? So how can we show that? We say, okay, let's call it s. Whatever it's equal to, let's call it s. Okay? We can also write it like this, right? 1 plus 2 plus plus n minus 1 plus n, right? That's, of course, the same thing, right? So that's s. But of course I can also write S like this. Right? Of course I'm allowed to do, I just switch the order. It's nothing. I just switch the order, right? Put that over there. So of course it's equal to that. But now, if I, okay, forget about this one. If I add these two, what do I get? So here I get what? 2s, right? And here I get what? N plus 1. What's this? N minus 1 plus 2 is what? N plus 1, right? And what do I get on this one? N minus 1 plus 2 is what? And they all are N plus 1, right? What's the last one? How many terms are there here? How many terms are there here? N, right? So how many terms are there here? N. So what is this equal to? Right? N times N plus 1. So S is what? That divided by 2. Right? So if we wanted to do this one in our head, we would say 1 plus plus 10. In other words, it's N, 10, times 11 over 2, right? Which is 55. Okay, so anyway, can't see that on the video, unfortunately. But anyway, the answer is 55, okay? And he says, then I gets incremented to 11, but it doesn't, it's now I is greater than the end value, so we end. We don't go through the statements again. Okay, does this make sense? Okay, here's the program, you just did it. Here it is. Okay, next is what we call do loops. And do loops are really basically the same thing, just allows you another kind of option for how you want to stop things when you want to terminate the loop. Okay? So far we just said I equals 1 to some whatever, or whatever. By the way, you don't have to start at 1 here. For example, here you could have put in like 2 to 8, or whatever you want. Okay? So you don't have to start at 1. Okay. Anyway, do loops give you another way of, again, repeating things, but just a different way to stop, or to have a different test for stopping. Okay? So a different type of loop structure is a do loop, also called do loops for short. This type of loop allows repeated execution of a set of statements, but with termination, loop termination, based on a conditional test. So before we go on with that, let's just look at an example. Okay, so let's build a VB.NET program to prompt the user for an input n, and then sum up the integers from 1 to n, and display that sum. Okay? So let's build a little program for that. And we're going to use the for next loop first, but then we're also going to use the do loop. We'll see how to use the do loop. So how do we do this in the for next loop? Well, remember, the user is going to supply something. How are they going to supply it? Are they just going to speak into the computer? Probably they're going to type. And we don't know how to implement speaking, right? Although I guess you could implement it with speech recognition, right? Probably get some speech recognition library from VisualBasic.NET, and you could implement it. And then you could have speech recognition, and it might not work all the time, but it might, right? So you might be able to do that. But anyway, we're not going to do that. So what are we going to do? We're going to have some place where the user is going to input it, right? So we're going to have a way for them to input their choice of n. Okay? So we're going to have this, right? N here and the sum there. And then we're going to implement it using a for next loop. Okay, so how do we implement it? So of course it's going to go in this button here. And here's his way of implementing this. So first actually, didn't we just do this? Didn't we just do that here? Where was that? Where was that? Didn't we just do that? Here. Yeah, we just did it. Right? This was the same thing, right? But here we just did it from 1 to 10. Right? Here we just did it from 1 to 10, right? This was sum up. Here, he said, calculate the sum of all the integers from 1 to 10. And we just did it. Okay? But now we want to be more general. We want to take the user's input and then calculate the sum from 1 to n, whatever the user puts in there. Okay? So let's see, how do we do it again? So basically what we just saw before, so we're going to, S is going to stand for what we called total before, in the last example. And N, what's the name of this thing, do you think? Can you figure out what the name of this box is? TXT input, right? That's the name of this box here, right? So TXT input dot text is what? Is what the user puts in here, and we're going to convert it to an integer using value. Okay? So that's going to be n. Okay, any question about that? I think value, this converts it to an integer, but at least I know it converts it to a number. I'm not sure if it's an integer or not, but okay. And then what? We're going to implement the same thing we just implemented, but instead of going from 1 to 10, we're going to go from 1 to n. But that's okay because n is already given a value up here, right? And so we're going to implement that like this, and then this is the same thing as before, but before we had total equals plus equals, what do we have, I? Or what did we have before? I forgot. I. So total equals plus equals I. Now it's S equals plus equals I. It's the same thing. S is total. So that we have that. And then finally, what do we do here? What's this thing? That's probably this thing, right? And this is what? The text value of it. And we're going to assign the text value of it basically S. Or we're going to format S using this kind of formatting. Okay? All right? And then this is exit. Okay, any question about that? Okay, so we could do it with the for loop, right? We just did it with the for loop. But there's another way we can do it now, also we're going to learn, called the do loop. So let's look at that. So here it is, this one, not this one, top one. So this is the do while loop button. So let's see how is it implemented. So we want to do the same thing that we just did, but we want to use a different structure called the do loop. So here, there's some things that are different, but S is not different. S is assigned to be equal to 0 here, just like it was assigned to be equal to 0 here, right? And then N is still the same. Yeah, N is still the same, right? Okay. But here, this we didn't do before. I didn't see this before, did you? Declaring I as an integer? I didn't see that. In fact, it wasn't there. We did this, for I equal da 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 da, right? This is a different structure, different syntax. Okay, so for the do while loop, you have to declare the index variable first. Okay, so we do that. Here. Here. So there we do it. Dim I equals index equals 1. I as integer equals 1. Okay? All right, next, we write do while, and this part is the same. S equals plus equals I, right? That's the same as here. S equals plus equals I. But here we have something else. What's this here? This wasn't in the for loop. What does this do? What's the word again? Index, but what's this part mean? What does he say? Increment the index. We have to do that, we have to write that here. Did we have to write that before? No, it was done for us, right? Here, it automatically does it. It's part of the for statement. Okay, but it doesn't automatically do it in the do-while syntax. You have to do it. Okay? So you have to add that in there. Don't forget to increment the index. Okay, is that clear? Okay, so that's the basic stuff you have to do. You have to add in this thing here, and you have to add in this thing up here. Right? Those are different than before, right? Now further, you have, of course, do while instead of for. And then you have this. Read this. What does it say? This is called a conditional statement. In other words, this is either true or false. Okay? It's either true or false. It results in a Boolean value. Something that's either true or false. So read it. What does it say? I is less than or equal to n. Okay? Now suppose n is equal to 10. Suppose the user puts in 10. And this is the first time we do this. So currently I is equal to what? 1. So this statement says what? Is 1 less than or equal to 10? Is that true or false? That's true. Okay? So as long as what's in here is true, then we go and execute these statements. If it's not true, we go down to outside of the loop. We go past this loop statement here. Okay? We get out of the loop. We jump out of the loop. Okay? So what did I just say? As long as this is what? True, we execute these statements. Otherwise, we do what? If it's false, what do? We jump out of the loop. In other words, we drop down here. Okay? Or as they say, control goes down past the loop. Okay? Is that clear? So the first time, I is equal to 1. So is this true or false? And n is equal to 10, I said. So is this true or false? It's true, so what do? S was originally equal to 0. Now S becomes equal to what? 1, right? And then what do we do next? We increment I by how much? By 1. And then loop means go back up. So we go back up, and what do? We have to check this condition again. So we're saying what? What's the condition now? Is 2 less than or equal to 10? And that's false, right? Right? Is it? No, it's true, right? Is 2 less than or equal to 10? Yeah, of course it's true. So this is still true. So what? We do it again. Now what do we get? S is equal to what? Before, last time S was equal to 1, now it's equal to, after we do this, now it's equal to what? 3. Okay, so S is now 3, and I becomes, where are we at? 2 now? No, 3. I becomes 3 now, right? So I becomes 3, and then again, then we're finished with the statements inside the loop, so then we go back up again, and we check again, and now it's 3 is less than or equal to 10. That's again true. And so we keep doing this until when? Finally, let's see, I becomes 10. That's still true, right? 10 is less than or equal to 10. That's true. So we go through, we add 10 to S. Right? We add 10 to S. And then what? We increment I by 1 so that I becomes now 11. Now we go up to here, and what happens? It's false, so we jump out of the loop. Okay, and we go on and do other things. Okay? In this case, we happen to output S. Right? In some nice format. Okay? Any question about that? Okay, and what kind of loop is this called? The first kind of loop we had was called a for loop, or a for next loop. And this kind of loop is called a do-while loop, or just a do loop, if you want to be generic. Okay, it's better to say do-while. Okay? Any question about that? Okay, let's think about it like this. Here. Okay, we have actually 4 different kinds of do loops. We have the do while loop that we just looked at. But another thing you can do is, instead of having this condition, this while here, you can also put just the word do on the top and put the while down here. And that will have a slightly different effect. Because in this one, you only evaluate these conditions if this, you only run these statements if this is true, right? But that's not the way it works here. If this, you check, because here we increment I, so I wouldn't get incremented if you put it down here. I don't know, maybe I didn't say that right. Somebody's smoking outside. Oh, I thought you're not supposed to smoke. Where is that? I want some of that. Okay, anyway. So, all right, so you can put the while at the end of the loop or at the beginning. Okay, and we'll see that there's going to be a slight difference in those. Okay, and then there's one other type of loop. Instead of using the while, you use the word until. Now, does while mean the same thing as until? No, right? You can't switch words like while I'm talking, you shouldn't be talking, right? I can say that, right? How about if I use the word until? Until I'm talking, you shouldn't talk. And that's kind of the opposite, right? Right? And you agree? So while and until are kind of opposite meanings, right? So if you use until, you're kind of getting an opposite effect. Okay, so we'll talk about that shortly. We'll look at it carefully. But of course the word while and until don't have the same meaning. In fact, they kind of have the opposite meaning. Okay? Any questions? Okay, so the do while loop. All right, let's read through this. The do while loop. The do while loop. Right? It says the do while loop. So that's a kind of loop called the do while loop. All right, the do while loop keeps looping while a loop condition is true. Right? As long as the loop condition is true, right? So what was the loop condition in the last example? I think it was I is less than or equal to 10 or something, or an n, right, whatever it was. And it tests the condition at the start of each cycle. And it halts when the condition becomes false, right? It jumps out of the loop when the condition becomes false. The syntax for the do while loop is this, right? Do while condition statements loop. Keyword do says start the cycle. Keyword while says test our condition. Test it at the start, it's at the beginning of each loop. If the condition is true, these statements are executed once. Every time it's true, they're executed. For example, adding numbers from 1 to 10,000 by declaring, incrementing, and cumulatively summing a block level variable called n. What does block level variable mean? So it's defined within a block, right? And a loop can be a block, is considered a block. So you might define it within the loop. And we could use the condition is n less than or equal to 1,000. Okay, so we would keep running this as long as n is less than or equal to 1,000. Okay? The keyword loop tells control to loop, in other words, to return to the do statement, and another cycle begins. Right? So the word loop down here says go back up. Okay, is this clear? again, I have to compliment the person who wrote this PowerPoint, because I think it's just really great, except for a few things that seem maybe not quite right, but it's very, very good. You won't find this such a good presentation, I don't think, in many books. I haven't seen it. Not nearly as good as this, honestly. I've looked at lots of beginning books. Now you might think this is too hard to read, or maybe you won't. I don't know. How did you feel about the last week's assignment with enumerations and that stuff? Was it doable? Did you understand all the material? Besides being able to do the homework, did you understand what he was saying? I don't think so, because he actually didn't explain the idea of properties that well. Now, I did give you some references in the syllabus, the online syllabus, where they do, and you also could have looked up, if you realized what you were supposed to look up, you could have looked up properties, creating properties in visualbasic.net, and you might have found some stuff that's readable. But actually, in that one set of slides, he kind of jumped a little bit and didn't define what is meant by property that clearly. But anyway, regardless of that, I really don't think you'll find anything as good. I haven't seen anything as good as this. And I've looked at, maybe 7 books and several different websites. And I think this is very good. But it's a little bit sophisticated, a little bit not super basic, his way of explaining things. But anyway, I think it's very good. So anyway, the do until loop keeps looping while a loop condition is false. So as long as the condition is false, sorry. Okay. Now we're switching to the do until loop. Okay? We just did the do while loop. So what's the difference between until and while? We said they're kind of the opposite, right? So the do while loop kept going as long as the condition was true, right? But the do until is actually just the opposite of that, right? We do it until something happens. So keep doing it until, until the condition is false. Right? This one, we do it until the condition is true, but this one, we do it, I'm sorry, I said that wrong. Let me try that again. This one, we do it while the condition is true. This one, we do it while the condition is false. So when you say do until, that means keep doing it as long as it's false. Okay? It's a little bit hard to say that. I think you can easily work it out yourself, but it's a little hard to say it correctly. But anyway, so keeps looping while the condition is false, whereas this one keeps looping while the condition is true. Okay? That's the bottom line. Okay? So you need to think of it that way in order to write it properly, right? Because you want the condition, you have to think about, do you want this to happen while the condition is true or while the condition is false? Okay? So if you want it to happen while the condition is true, you use which one? The while loop. But if you want it to happen while the condition is false, you use the until loop. So let's look at this example. Here, we just did this using the do while loop, right? We just did this. This was to do what? To program for summing the integers from 1 to n, right? Now we did it 2 ways so far. We used the for loop, but then the second time we used the do while loop. Now, this will keep running as long as this condition is true, right? I'll make the same mistake 100 times. But we do this while the condition is true, right? But if we write, instead of while here, if we write until, then we're going to do it as long as the condition is false. So here we wanted to add up, what was this, from 1 to n, right? So as long as I is less than or equal to n, we'll keep going. But if we use the keyword until, then we have to write what? We want it to keep running as long as this is false. So what do we want to write here? I is great. So as long as I is less than n, we want to keep running. But we don't write less than 10 here. We want to write when it's the opposite of that. So you have to write when I is greater than 10 or greater than n. Right? That's just the meaning of until in English, right? It's not really, has nothing to do with anything else except for the meaning of until in English. Right? You agree? Okay? So it's not really mysterious, but it is a little tricky, right? So you have to pay attention to it. All right? So if we want to implement this button here, the do until, instead of the do while loop, we have to change the condition. The other stuff is all the same. But we have to change this condition. Okay? Get it? All right? So that's called the do until loop. So it gives you some flexibility, but it also can cause you to be confused. But it does give you more flexibility. With more options, people tend to get more confused, right? If in life you don't have any choice in what you have to do, you're not going to be confused. You might be unhappy, but you won't be confused. It's not the same thing. Being unhappy is different than being confused. It might both be unpleasant, but they're not the same. Okay? So if you don't, so the more choices you have, the more confused, but the more options you have. So here they give us another option. So that's an option to be more confused. Okay. Anyway, so that's that. Now, next one is okay. Now, do you see any differences here and between this and the last screen? I just changed the screen. You might not have noticed. But I just changed the screen. Do you see any differences here? You haven't seen this screen. We haven't talked about this screen. We just talked about a screen that looks similar, but not quite. What's the difference between this screen and the last one? The conditions come where? At the end, right? In the last screen, we had do while up here, right? And we also had down here, we had do until up here, right? But we don't have that here. Where's the while in this one? Down here after loop. And where's the while, where's the until here? Here. So these can produce different results than the previous screen. And in this case, they won't. But they can. Because you're executing something, you're just testing whether you should go through one more step at a different place. So that can result in some difference. Okay? But they don't result in any difference here. Okay? Because all the other code is still the same. It's just where we put the condition. Okay? So you can do the do loop while and the do loop until. Okay? Any questions? All right, let's go back to the previous one, where the while is on the top and the until is on the top, and let's just read what the notes are here. Note 1, the test for both of these do loop types is at the top. Okay, we already said that. And note 2, the difference between the top implementation up here and the bottom implementation down here is the use of logically opposite thinking, while versus until, which requires opposite test conditions to give the same result. Okay? So you need different test condition here than you do here. In fact, the opposite test condition. Any questions so far? Okay, what time is it now? Okay, we have 12 more minutes. Okay. Well, we we have more to do. But, okay, so you're going to have to do this also. Hand this one in. Okay? Okay, this is called nested loops. So nested is basically, you know what they call Russian eggs? Or, yeah, I think they're Russian doll boxes or something like that. Have you ever seen those things? You know, you have a box like this, and then another box inside there, and then another box inside there, and another box inside there, right? You know that? You've seen that, right, somewhere, right? So that's the idea here of nested loops. So we have one loop on the outside, and then another loop on the inside of that loop. So what does that mean? If you have a loop on the outside, like for loop, for and loop, and then inside here you have another loop, for and loop. Now let's say the variable here is I, and the variable here is j. Is that what they use? Yeah. Where I equals 1, 2, 10, and for j equals, say, 1, 2, does he do 10? Okay, 10. Okay, so what does this mean? Let's suppose I just want to print. Does he do that? Let's say I just want to print, or a message box. Or no, let's say he does list data. LST data dot items dot add. And look at what I'm going to add. Watch this. I, and then a comma. Oh, I need the ampersand, right? Ampersand. And just put a comma, comma here. Okay, that's just a comma. And then ampersand and j. Okay, now think about, how is this going to work? Let's think about it. First of all, of course, it's going to be in a list box, right? So what's going to be in this list box? What's going to be the first thing, first line of this list box? And you have to read this. So I goes from 1 to 10, right? But what happens is, I is first, of course, what? 1. Then what do? We're supposed to do what? We're supposed to implement all the statements inside the loop. Right? Right? Inside what loop? Inside this loop, right? This goes with this, right? So where are the statements inside the I loop? He used red, but I don't have red up here. But he also used green for statements. So I'll put green here. Okay, we had like a pink box, but you can also use green because he used green statements. So we're supposed to we're supposed to run all of this when I is equal to what? 1. Right? When I is equal to 1, we're supposed to run all this. Then when I equals 2, we're supposed to run all this. When I equals 3, we're supposed to run all this, and so on, right? Isn't that what we're supposed to do? So, now I don't know what's going to happen here, but I know that I is going to be 1. Right? But we're going to run this whole thing, right? So what does that mean to run this whole thing? We're going to go from j equals 1 to 10. All the while, I is equal to 1. So we're going to have I equals 1 and j equals 1. But then we're going to have I equals 1 and j equals 2. And then we're going to have I equals 1 and j equals 3, and so on. This is the same kind of idea. I don't know if you've ever done this in math, but it's like doing this. Doing double sigma signs. The same thing. I don't know if you've done that, or if you got a headache when you did that, but it's the same thing. But anyway, maybe this is easier to understand, or maybe that is, but they're the same. So, anyway, so what do we get? while I is 1, we have to run through this loop 10 times. So we get 1, comma, 1. Then we print out 1, comma, 2, 1, comma, 3, 1, comma, 3, up to 1, comma, 10. But that's, okay, so we went through this loop a full set of times, but we didn't go through this loop a full set of times. In fact, we only went through this loop once. Now we have to do what? Increment I to what? 2. And then what? Then we have to run this again. So what are we going to get now? I is now 2, so we're going to get 2, comma 1, 2, comma 2, 2, comma 3, so we're going to get what? 1, 1, 1, 2, 1, 10, 2, 1, 2, 2, 2, 2, 10, 3, 4, all the way down to 10, 10. Right? And that's called a nested loop, just like those Russian dolls, or those Russian eggs. Right? So this is an example of a nested loop. And they're kind of complicated. Right? But, and like, thinking about how to, if you wanted to express that, suppose you said, oh, I don't know a loop. I didn't think of a loop yet. I just know I want to write 1, 1, 1, 2, 1, 3, 10, 10. How do I get that? How can I do that? You have to sort of, I don't know. I guess you get used to thinking about nested loops, then it's easy. You say, oh, I could use a nested loop. But you have to write it yourself. It's easier to read the code, in this case, than to figure out, go from here to this. At least for a while, unless you practice. Okay, any questions about that? Okay, now, you can quit loops early. So you may choose to quit a loop prematurely based on some condition. So you might say, if something happens, then I want to escape the loop. Okay, and you can do that. Obviously, you would like to be able to do that, right? You'd like to have the ability or option to quit a loop in the middle based on some condition. And you can. You have an exit for loop. You have the exit for keywords and the exit do. And usually you put them, you use them in conjunction with an if-then structure. So you say, if something, then exit for, if you're using a for loop. Or you say, if something, then exit do, if you're using a do loop. Okay, does that make sense? So there are ways to exit functions. Now, you can also have infinite loops, which you generally need to avoid. Now, if you go back to, let's go back to the simplest one we had, which was the for. No, not the for. For won't generally give you infinite loops, but do could give you an infinite loop. Look at this. Not that. Look at this. Suppose I forgot to put in this statement here. Suppose I forgot to put in this statement here. What does this statement do again? It increments I by 1. And then what do? We keep testing, right? Whether I is less than or equal to n, right? Suppose I forgot to put this in. Then I never gets any bigger. So this is always, if this was true once, it's going to be true forever. So that would be an infinite loop. You wouldn't want to do that, right? Almost never would you. I mean, you don't want an infinite loop, basically. Okay? If you do run it, if you do get an infinite loop, you can do certain things to get out of it. Here. One thing you can do is ask Visual Studio to stop the run with the stop debugging button. Okay, you can try that. And if that doesn't work, you can always use, in Windows, you can always use, well, I guess we're talking about in Windows. You can always use Control-Alt-Delete. Okay, and then, that'll bring up the task manager and you can force the program to quit. Okay? Hopefully. It used to be, back a long time ago, you might not be able to do it, like if you had an old version of Windows, like before Windows XP, I forget what the Windows 95 it was called. Then sometimes you couldn't get things to stop. But now they've fixed they've Windows 7 or 8, you don't usually have any problem with that. Okay? All right. So your homework is to do this one here and hand it in, and then this one, the greatest common divisor. Now that is going to take some work. You're going to have to think a little bit hard about that, but we already have this, okay? So it might be hard, but if you work through it yourself, you'll learn a lot, and it will really help you for your programming expertise. So just don't give up. Try to work it out yourself. You probably will get it eventually, and if you do get it, you'll have learned a lot. Because programming doesn't happen just by reading it. You have to struggle a little with harder problems. Hopefully they're not too hard. Hopefully they're given to you at a place where you can learn something from them, and it will add to your current knowledge instead of just sort of out of the blue. But hopefully this assignment will relate enough to what we've learned so that it will kind of solidify what you've learned and give you more strength in terms of what you've learned. So don't give up on it. Just try to work it out yourself, because it's really an exercise for you, and it will help you a lot. Okay? So try it out. Don't, it's not like you're going to ruin your grade or anything, but it's going to help you a lot in terms of your confidence in programming. Okay? Any questions? Okay, that's all.